Hello there, welcome back to today's video. Make sure that you have the title written down, and then make sure that we are doing our full purple pen. So full purple pen, full working out, okay, full explanation. So we need to make sure that we understand any question that we go wrong. We need to make sure that we are understanding it fully now in this particular case. Now question one A, B, C, and D. That was very well answered. Okay, so what was the distance of the race? So you guys were able to look at 60, and you were able to identify that this was 60 kilometers. So this was very good. And how long did it take for the horse and the rider to complete the race? So pretty much start and finished. So that was 5 hours. So that was like 5.5 hours. So again, so that was very well answered. Now, what distance did the horse and the rider traveled the first 2 hours? So 2 hours was very good as well. So 2 hours was here. So we're able to go back up into this here and go across to get 30. So this was also answered very well. So 30 kilometers. Okay. And then how long did the horse and rider stop and rest during the journey? So stop and rest. So you guys were able to look at that as well. So you can see that it rested between this side here. So this one it rested. So this was between this and this. So that was 30 minutes as well. Okay, so 30 minutes indeed. So this was very good. Now, not counting between the time rest, which moving the slowest. So this was answered as well. So slowest, you can actually see that between D and E, it was moving the slowest. So between D and E. So D and E. Now the question says, give a reason for your answer. Why do you think it was moving the slowest between E and D? Now look at the slope. So look at the slope. So this one here, look at the slope of this one. Okay, look at the slope. So look at the slope and compare it with the other slope. So you can actually see that the slope is different. So what is happening is, you can just say between D and E, the okay, so between D and E, the graph has the least steep slope. Okay, so the slope is very low. So you can see that here. You can see that this one A, the slope is high. This one down a little bit. This one's very steep, and then this one is very shallow. So D and E, you got the lowest slope possible. So all in brackets the lowest gradient. So lowest gradient or lowest slope. Okay, that's why. Now here we need to fill in the blanks. Now the weight of an object is the force of gravity. Okay, so remember, weight is the force of gravity acts on an object. And when you drop something, first of all, it's what? What's going to happen when you drop something? It's going to start moving down. So therefore, it's going to accelerate. Okay, so it accelerates. Now, as it goes down, as it accelerates, what's going to happen? Air is going to go against it. So air is going to go against it. So therefore, that is the air. Now, the air is doing what? So we call this air drag or air resistance, and this is also air friction. So force of friction. Okay, because friction, you can say either air drag, air resistance, that is friction acts against it. Eventually the object, what happened? Now this is a question linking with terminal velocity. Okay, so therefore what happened is, therefore the object start to falls at a steady speed. Okay, so that is the terminal velocity. So the speed is the same. So reach terminal velocity. So in other word, this means terminal velocity. So constant speed, so steady speed, constant velocity, or constant speed. Okay, so this is this one here. Again, if you got this wrong, make sure that you have the correct answers written down. Now, we have a person running, and then we have the equation here, and we need to use the equation in this case. So the equation, I'll just write it down here. Change in velocity, you know the change in velocity already. It's given to you there. Okay, so it's 9 divided by 2, so this is 4.5. So the answer here is 4.5. Okay, as you can see, this change speed here, change velocity is linked to this one, and time is 2 seconds. Now, what is the unit for acceleration? The unit for acceleration is this one here, because remember, it is change velocity, so it's meters per second divided by second, so meters per second squared. Okay. Now, this one, velocity is of an athlete is the speed of an athlete in a particular direction. So that's how we define velocity. So velocity is speed in a given direction. Okay, now here we need to draw a graph. Now, how do we know what graph to draw? So first of all, we need to go back to the question. The question tells us that it is accelerating constantly. Okay, so accelerating constantly. So what do we see? So constant acceleration. So you look back into your book. So this here is a straight diagonal line. Okay, now it means that we're going to start here at this point, so 0 0. Now where are we going to end? So we know where we're going to end. We know that it goes to 9. We know it goes to 9 meters per second in 2 minutes. So 2 minutes, so 2 seconds, sorry, so 2 seconds, so 2 seconds here. So it's going to go all the way to 9, so it's going to be here. So therefore you can have this line that's going to go through those, oh, it's the line that goes through those points. Okay, so let me see. So line, let me delete this. So a straight line that go through those points here. I'm going to try to see whether we can draw this. Okay. Nope, so it's going to be a straight line that go through there. Okay, that's wrong. So I need to draw a straight line. So how can I draw a straight line? Okay, so I'm not able to draw a straight line. Let me just draw the straight line and come back. Okay, so make sure that you use a ruler. A straight line again. So from 0 0 all the way to 9 2 seconds here. Okay, so 9 seconds. Good. Now this is terminal velocity again. So this is terminal velocity. So make sure that you check your notes for that. So what we have is force X. So this is air drag. So this is air resistance or air drag. And the force down is this is the weight. Okay, that's the weight. Now, why force X act upward? So why is the air resistance acting upward in this particular case? Now, air resistance. So when you move, what happens? You feel the air in your head. Okay, so you feel the air in your face. So air resistance acts upwards because it opposes movement. So that's what air does. So whenever you are running, the air is always hitting you in the face because the air is always opposing you. So the air is always opposing your movement. The air opposes movement. Oh, yeah. So that's why it goes against you. Now, what's going to happen? So which of the force is bigger? Now, at first, the forces are bigger. So what's happening to the object? The object is falling down, isn't it? The object is falling down. So if the object is falling down, so here, there. So the object is falling down. So it means that the weight is bigger. I mean, which of the forces? X is bigger in this case because the weight must be bigger for it to keep on falling. Okay, now how does this unbalanced force going to affect the diver? Now, since it is falling, what's going to happen? So two things going to happen. Okay, fall towards the earth. Okay, so that's what's happening. So falls are falling towards the earth. Okay, all right. Okay, so at a faster rate, at a faster rate. So this means that it's falling. It is acceleration. It is accelerating. So the object is falling, yes, but when it's falling, it is accelerating down. So this guy is falling faster and faster, so it is accelerating down when it's falling. Again, so it's 2 marks. So how is it affecting? So it is accelerating the object. The person is accelerating towards the Earth in this case. Okay, that's what's happening. Now here, after some time, the parachute opens up, and then here's a diagram. Okay, so you can actually see. Now, after a while, the forces are balanced. Now, if you remember, so when parachutes open, now if I draw the object here, so you got the object here, the person, you got the weight of the person. Now, when the parachute opens, what happens is the air drag is bigger. So air drag is bigger. Okay, that's what. So therefore, it decelerate massively. Okay, now after a while, the forces are balanced again. So therefore, so after a while, so let's say after a while, what happened is you got the object again. Now the weight is the same. So the weight is the same. So therefore, the air resistance has decreased now. So the air resistance has decreased in order for it to be balanced, isn't it? Because the weight doesn't change. So how can it be balanced? So the only thing that must change would be the air resistance. So the air drag must change. So how will it change? So x, what happened to x? What happened to x? What happened to x? So x is, I think I made a mistake here. Actually, this is y. So y is greater. So this is my bad. So y is greater. Y is the weight. Y is greater. My bad. Okay. Now x what has happened after a while. So look, when it opened, air drag was bigger, and then after a while, for it to be balanced again, air drag must go down. So therefore, x has decreased. Y, what has happened to y? Y is the weight. So y has stayed the same because the weight doesn't change. Well, the weight still the person. Yeah. So the person is falling, still the same person. So weight stays the same. And what happens to the speed of the skydiver? Okay. What happened to the speed of the skydiver? Okay. What happened to the speed of the skydiver? The speed of the skydiver has decreased. Okay. So when it opened the parachute, it decelerated massively. So after a while, speed has gone down. Okay. So that's what happened. That's why the parachute saved the person. The parachute opens, increases the air resistance, decelerates the person massively, and after a while, the air resistance goes down, so everything's balanced, and then that also reduces the speed even further. Okay, so this is how it is. Again, so make sure that you have the diagram down. So make sure that you draw the diagram. Draw this. Okay, so this is your explanation there. Now this one was fine. So density is equal to mass divided by volume is equal to 45 divided by 5. Okay, 9, and then we need to put the units to get the marks. So units is gram/centimeter cube, because look, it's gram and it says centimeter cube here. So you need to use the same unit. Now find mass. So mass is equal to density times volume. So density is 5 times volume is 4. Okay. Okay. Find the mass. So mass is equal to density times volume is equal to density. We know 190 multiplied by volume. So this will give me 570. Now what is the unit? Now look, the unit is in kg, so therefore the mass will be in kg. Okay. Again, if you got this wrong, make sure that I see all these steps. So 3 steps there: equation, numbers in, answer with the units. Now here, find the volume. Now we know it is a block, so it is a block. So therefore the volume is equal to length times width times height. So equal to 7 times 5 times 2. Okay. So this will give me 70. What's the unit? Unit is centimeter cube. Okay, look, they're using centimeter, so therefore we use centimeter cube here. Okay, now what is the mass? The mass is the mass we know, so mass is equal to density times volume. Now what is the density? We know it's 11.5 from the question times 70, which we already calculated. This will give me 85805, and the unit is, what is the unit for mass here? So look, the unit that they use for mass is grams, so therefore the answer is in grams. Again, I need to see the full working out. Equation, numbers in, and here we go. Right, now we need to work out the density of an irregular shape. You may include a diagram if you want. Okay, now first of all, I'll start with the equation. So here we go. So equation, density. So let's take a look. Density equal to mass divided by volume. Now, how are we going to get the mass of the object? So measure mass of object using, what device we use? Using a scale. So we need to use a scale to get the mass. Okay. Now once we got the mass, we need to find a method to get the volume. So how can we get the volume? So that's why we're going to be using the cylinder method. So what we're going to do first is we're going to have a cylinder. Okay. So here we go, cylinder. We're going to pour some water in it. Okay. We're going to measure how much water we have in this case. So let's say here we have 50. Okay. Let's say we've got 50. Okay. So let's say we've got 50 centimeter cube of water, and then what we're going to do next? Next, we're going to same beaker, well, same cylinder. We're going to gently lower the object in it. So in this case, let's whatever object it is. So gently lower the object. Okay, so we're going to put the object in the water. Okay, and what's going to happen is the water level is going to rise. So the water level is going to rise. Now the water level has gone here, and the object is here now. Okay, so the water level has risen to, let's say it's gone up to 70 centimeter. So therefore the difference will give us the volume of the object. So here we're going to go. So okay, so let's take a look what we're going to say. So here pour water in measuring cylinder plus record it. So we need to record it. Okay, next, gently put the object inside the cylinder. Okay, so water level rises plus record it. Okay, so the difference in water level gives the volume of objects. So in this case, so the difference in volume is 70 take away 50, so this is 20 centimeter. So therefore the 20 centimeter, that is the volume of the object. Okay, and finally, using equation, we can find density. Okay, again, so make sure that you have the full version in. So 1, 2, 3, 4, 5, 6, 7 are broken down into 7 points, and the diagram there. Again, so make sure that you have the full version in. Okay, good. Now we need to calculate the weight. Equation for weight is W is equal to mass times G. Now, what do we know? Calculate the weight. So this equal to mass is 1.1 times 10. Okay, so this is 11 Newton. So 11 Newton. So Newton, remember, weight is a force to Newton. Now the book is taken to the moon, and the weight of the moon is this much. What is the gravity on the moon? So therefore, same thing again. Okay. Now the moon has a mass of 1.1. So the one is mass is the same on different planet. Okay, so copy this down. Copy this down. Mass is the same as the planet. So therefore, what's going to happen is, so I'm looking for gravity. So therefore, W divided by mass equal to gravity. So therefore, W is what? 1.6 divided by mass is 1.1 is equal to G. So therefore, G is equal to 1.45. And then what is the unit? The unit is very important. The unit is N/kg. Again, so make sure that you have the full version in. So 1, 2, 3, and the last one, 4. Okay, good. Now, what quantity is calculated underneath the speed time graph? So speed time graph, so the area underneath the speed time graph. So this is a distance. Okay, so this is a distance. Okay, now here what's happening here. So we've got speed and then we have time. So at this point, what's happening? It is slowing down. So look, it is slowing down. So here it is slow down. So this is decelerating, deceleration. And here what's happening? Here it is constant. So therefore the answer is A. Again, so make sure that you write this down. So write down. So write down. Okay. Now the forces are balanced. What happened? Okay. Now the forces are balanced. Few things can happen. So forces are balanced. Two things can happen. One. Okay. So object is still, or object keeps on moving at constant speed. Again, write this down. So write down. Therefore, the answer is D in this case. Okay. Now this one, we're looking for the resultant force. So resultant force. So this one, resultant force is 0 Newton. This one is 1 Newton to the right. This one is 6 take away 3. So this is 3 to the right. This is 3 Newton left. So therefore, the answer is C. Okay. Good. Now, which one is not true? So which one is not true? Okay, so let's take a look. Weight is a force acting on mass, while due to gravity. So this is correct. So this is correct. This is correct. So this is not correct. So therefore, the answer is D in this case. Okay. All right. So here we go. On the different planets. So what happened is the mass does not change. Weight changes due to gravity. So the mass of the person will not change. The mass of the person will stay 70. Okay, but the weight is going to change. So therefore, the answer is going to be A in this case, because the mass is 70 and the weight has changed in this particular case. So the chain has changed. Okay. Now, which one is iceberg? So iceberg floats. Okay, so the floats. So if the float means, it means that, okay, its density must be lower than seawater. So if it's floating, it means that it must have a lower density. So density must be lower. So write this down. So write down. So therefore the answer is D in this case. Okay, so hopefully you fully open your work again. So do pause the video and focus on this. So once you're done, you move up. Don't forget to subscribe.